Hey guys, so in the last video we saw how we can render a plain white cube using the index array. Now our next step before we move on to textures, let's try to render a cube with six colors on its six faces because that's pretty close to what we will be doing with our textures. So if we look at this diagram, I have colored this cube on GeoGebra exactly how I want to color it in our application. The six faces have six different colors. So how can we do that? Previously, we were just rendering a white cube. So we could get away with using only eight vertices to define our vertex array. But when we want to render six sides with six different colors, what we have to understand is that each vertex is gonna share three colors. In this case, this vertex will have color red, blue, and green. This vertex right here will have color yellow, red, and blue. Each vertex will be repeated three times as every one of them will need three colors. Because if we just define one color for this, it won't properly blend when this surface is being rendered or this surface is being rendered. So let's see how we can do that. For that, as you can see, I have written this updated code here. This cube vertices now mentions four vertices for every face. As you can see, what changes is we have to pass this color every time because now our vertex shader has every vertex has another element to it. Previously, it only had position. Now it only has color information. So one vertex is now made up of six floats. Instead, previously one vertex was made up of three floats. Now it's made up of six floats. So some things that will change is our code when we are actually setting our vertex attribute pointers. So previously we were just passing the position of this cube vertex into the ID 0 of the vertex shader, and we were saying it will have three elements, three floats, and yeah, the stride was previously just three, right? Because we were getting a new vertex after every three floats. But now, because a vertex is made up of six floats, three floats for the position and three floats for the color, this is going to change. Our stride changes from three to six. So a new vertex information appears after every six floats. Our vertex shader program is here. Now it takes another variable as input, a vector 3 called a color. All it is doing is passing this color as it is to the fragment shader. And what is fragment shader doing? It is taking this color data in and it is setting the color as the fragment color. So we are not doing anything fancy here, just setting the color as we are getting it. Now, how can we pass this second attribute, that is vec3 color, just like how we pass the first attribute to the vertex shader? We use the GL vertex attribute pointer. We set the location of the attribute. In this case, it's 1 because it is mentioned here, it is 1, location 1. Then we mention that this attribute will get three values. Each of those values will be a float. This value will be repeated after six floats because our stride is 6. Now this last parameter, we were setting it to 0 before. In our vertex array, the position of a vertex starts immediately, right? Like the 0th index is where our position starts. But color data starts after first three floats, which are the position. And it repeats just like that everywhere. So we have to mention that here. That's what we are saying here. The offset for the color data is going to be three times the size of float. After that, we enable both of these attributes. Yeah, I think that is it. Nothing else changes. The only two changes we are making is we are adding a new attribute to the vertex shader called a color. It takes this color and passes it onto the fragment shader as it is without doing anything to it. And the fragment shader uses that color for its fragment color. Now, how will each one of these surfaces get a different color? Because we have mentioned it to be like that in our vertex array. Because these four will get a color red. These four vertices will get a color white. These four will get a color yellow. Now, if we run this code, so yeah, we get a colored cube with each face having a different color. But why is it not looking like this, right? We want our front face to be red and the right face to be green. What what could be happening? So what is happening is our camera is currently not where our camera is in GeoGebra. Our camera is somewhere here. That's why we are seeing the white face, green face, and the blue face. How can we change our camera? We need it to be in the positive x-axis, the positive z-axis, and also a little bit above. So a positive y-axis. We can see here our camera position is currently in the negative z-axis, which is somewhere here. If we just change it to +3 and render this, yep, we see a cube just like we are seeing it here, right? So red face here, green face here, and a blue face here. And in the next video, we'll see how we can replace that vertex color with an actual texture. So yeah, see you in the next video.